40% of steel production comes from smaller producers, secondary steel producers. So, looking at the entire ecosystem, probably we'll need to have, and that is where probably industry PhD Chamber of Commerce and Industry can step in and talk to other people. We need many more accredited professionals to carry out monitoring and reporting of emissions across various plants in India, steel plants in India. So that is there. I think I'm going very slow, but probably I need to speed up here. Most of the things have been said. The point is, how do we make this green transition? There is no single pathway. There are multiple pathways. Right? And ultimately, it comes down to two things: technology, availability, and accessibility of technology. The problem perhaps our Indian steel industry is facing is that when it comes to PAT, I am sitting here in the Ministry of Steel, I am not sure to what extent there is a diffusion of PAT in Indian steel sector, particularly in the secondary steel sector. So I will be happy if PhD Chamber kind of enlightens me, and we are working on that, but again, work in progress. Second thing is that for most of this technology, we depend on imported technology, right? See, a similar problem that we face is in terms of capital goods. So capital goods also for steel sector, we depend heavily on imports of, same people, generally, SMSs, private. So somehow our domestic capital goods industry has to step up and cater to the demand on techno-economic feasibility of almost all the available technologies here. And for a businessman, if suppose Aparajita is in Tata Steel, she has to make a choice of choosing a technology to improve her, CO2 emissions, carbon footprint. She will look at whether this makes sense for me commercially. How does it impact my bottom line, right? And that is the whole story, I guess. So even if the technology is available, the availability of technology to Indian steel sector, that is still a very costly thing. How do we crack this? Green hydrogen is one area which is absolutely promising for us. And I believe in karma. And I think 5-10 years down the line, EU will depend heavily on India for supply of cheaper green hydrogen, and perhaps then we will do a CBAM kind of thing to EU, and we will do some kind of extra carbon pricing or export duty on green hydrogen to EU. Who knows, right? So okay, I'm a very optimistic person. I'm very optimistic about my steel sector. My steel sector is going to figure out all these things on its own. Even if the international forces kind of push us to the corner, my steel sector is very capable. Not for nothing, we are the second biggest steel producer. So green hydrogen is something I see a lot of potential in. And who knows? For example, think of it 15 years back. Solar power used to be looked at a very costly option. No longer anymore. Now solar power is at times cheaper than our thermal power. Who knows, 10 years, 15 years down the line, we will have green hydrogen coming out at a reasonable cost and taking care of our cost dynamics there. One thing that I would like to emphasize is carbon capture utilization and storage, CCUS. The funny thing here is that the more we utilize it, the less is the requirement of storage. So, and there also, perhaps we have got a vast coastline and which has a huge potential of storage, and who knows, 10 years down the line, the developed countries will look for India to provide us that avenue for their carbon storage. I don't know. I mean, that's still very futuristic thought, but still this utilization part, carbon capture utilization part is essentially very important. And that is where the gentleman from JSPL, Mr. Naveen Ahlawat, when he said of carbon circularity, that becomes extremely important. How do we capture the CO2, bring it in the loop using CO and then reutilize it. That is something we need to replicate in many other steel plants in India. When we look at multiple pathways of greening, while making a decision, we have to, the overarching consideration is how to minimize this cost of green transition. And that is where perhaps a lot of due diligence will need to be done. I am not sure whether cost is exactly quantified for each and every pathway as of now. But yeah, the industry, the government, everybody will have to, this is a common problem, we'll have to sit together and we'll have to work it out. I'll think of the same issues: energy efficiency, process efficiency. These things remain extremely crucial. Very quickly, I'll come to the point which Mr. Anil Chaudhary mentioned, that the financing requirement is going to be huge. He mentioned a number of around $100 billion?
100 billion.
Which is like 8.5 lakh crore, or 8.5 trillion rupees. That's a humongous number actually, quite intimidating. And we in the ministry are quite mindful of this massive financing requirement. So we have not put a number of X billion but still. And last week we had a meeting with officials from ADB, and I'm hopeful that the thing is that now steel companies will have to come up with projects aiming at decarbonization of steel sector and decarbonization projects. And my interaction with multilateral development banks is that they are willing to put in money. Government of India is willing to rope in. So if we think of all this $100 billion coming from budgetary resources, that's very utopian. We are not that rich country. We don't have that rich public finances. So we will have to necessarily supplement public finances by way of mobilizing finance from multilateral development banks, from private FIs also. Why not? I am in talks with ADB, and going forward in the near future we'll be in talks with World Bank and BRICS NDB also. We are quite hopeful, and they have promised good money to be made available to steel sector for decarbonization projects. Now now I expect the steel industry to come up with decarbonization projects, and other than that, much of this can be in the form of project financing, but again some of this can be in the form of public financing also. As for government's money, I think one area where everybody needs to contribute more, and that is investment in R&D. And when I say this, both government and private investment will need to go up. I am not sure to what extent existing R&D facilities of steel companies are gearing up to the challenge of green transition and all. For all you know, most of these breakthrough technologies will come out of some laboratories of IITs or Indian Institute of Science or some CSIR labs, but then we'll have to work very closely, and perhaps some kind of consortium approach of R&D will have to be worked out. We are very mindful of this need, and we are working on this. That is one area where perhaps government's investment is much more required because of the huge positive externalities involved there. But that's it. I'll stop here. We have comfortably outrun the time allotted to us. I am not going to take any question. All the questions may please be directed to Mr. Anil Chaudhary. He is the most knowledgeable.
Last but not the least, I would like to invite our co-chair, Mr. Aman
Kumar, IES Economic Advisor, Ministry of Steel, and Mr. Clement, Advisor, Indo-German Energy Forum, and Mr. Anil K. Chaudhary, Chairman, Mineral and Metal Committee, PHDCCI, former Chairman, Sale and Group CEO, Steel. Mr. Praveen Mishra, Joint Managing Director, LSI Engineering Consultant, Mr. Aparajita Agarwal, Senior Area Manager, Steel. Mr. Ranjit Mehta, I think he's not here, Executive Director PHDCCI, and Ms. Millie Dubey, Director PHDCCI. Honorable dignitaries, diplomats, esteemed guests, respected delegates, and media persons. As we come to the conclusion of the inaugural session conclave of green steel, India journey towards low carbon energy manufacturing, I'm honored and privileged to extend a heartfelt vote of thanks to all those who have made this event a resounding success. First and foremost, I extend my heartfelt gratitude to our esteemed Chief Guest, Mr. Ashwini Kumar, IAS Economic Advisor, Ministry of Steel, and Guest of Honor, Mr. Clement, Advisor in Indo-German Energy Forum, for gracing his occasion on this invaluable science and perspective. I must congratulate Mr. Ashwini Kumar for taking various initiatives at the Ministry of Steel, and would like to thank him for the bottom of my heart for accepting our invitation on such short notice. I would also thank Mr. Praveen Mishra, LSI Engineering and Consultant, for giving a brilliant presentation, for being our knowledge partner for the conclave and helping us in bringing out a knowledge report. Thank you, Aparajita, for enlightening us about the various initiatives being taken by the Tata Steel for decarbonization. I'm also thankful to Mr. Anil K. Chaudhary, Chairman, Mineral and Metal Committee, PHDCCI, for the same team remarks, for giving us global perspective and decarbonization of the steel sector and its significance for India, and also his constant guidance for making this conclave a reality. I would like to thank the Ministry of Steel for supporting the conclave into the American Chamber of Commerce for being supporting association, Steel and Metallurgy for being the media partner, and Vizag Industrial Scan for being the industrial partner for the conclave. I would also like to extend my gratitude for all the dignitaries, government officials, and industry leaders who have taken out their busy schedule time to joining us for today. For presence and active participation has been cornerstone for this conclave success. Your enthusiasm and commitment to advancing green steel manufacturing in India are truly inspiring. Together, we can pave the way of greener, more resilient future for the steel industry and for our nation. Thank you once again for the unwavering support and dedication. I look forward for your continued partnership in shaping India's journey towards low carbon steel manufacturing. Wishing you all continued success and prosperity. Thank you.
Sir, आपका एक
into a topic which is use of green hydrogen in steel manufacturing. We as a company, I represent a company called Acme Clean Tech. We are very much into green hydrogen manufacturing, and we'll let you know how exactly we are playing a crucial role and a leading role in being and providing the best green hydrogen solutions to this sector. But before we do that, often we have discussed all these points earlier also, that how because of the policy, because of the process constraints, and because of the current technical challenges, how the green steel industry is a hard to abate and carbon intensive sector, and the CO2 emission ranges from the world average is 1.85 tons, as we have discussed earlier, and India average is somewhere around 2.15 tons per TCS of green crude steel, and we intend to bring it further down. India is a signatory to Paris Agreement, and in COP26, it has set up a very ambitious target to decarbonize and to bring down the carbon emission levels to by 1 billion metric tons by 2030, and eventually achieve a net zero target at by 2070. So that's a stiff target to achieve, and in India, the steel manufacturing unit comprises of somewhere around 10 to 12% of the total carbon emissions. So it becomes a very crucial sector, and it becomes a focus area to decarbonize the sector. Talking about the processes, we have talked about that POF and EF are the two prominent processes that are being used. And in India, the crude steel manufacturing production is second largest in the world. India is the second largest producer of the steel in the world. But then the difference between the first largest, that is China, and the second largest, that is India, is quite significant, and it has a lot of catching up will be done, because India is a progressive country. We have heard Mr. IES saying that India growth trajectory is phenomenal, and with the growth, the steel consumption will also increase. So currently, India is producing somewhere around 154 million metric ton is the capacity that is currently set up, and in times to come, it is envisaged to achieve a target of 300 million metric tons by 2031. So stiff target setup, but then the challenge is also huge, and that we all are set. So this slide is already discussed in the presentation by JSPL earlier, that the steel sector is adopting a multi-pronged strategy to decarbonize itself, and it's not a one-pronged strategy, but it's a multiple strategy, like carbon dioxide minimization, carbon dioxide avoidance, circularity, and CCU. I will be focusing more on the carbon avoidance principle, the strategy which the green steel manufacturing sectors are adopting, in which in the blast furnace and the DRI technology, they are trying to use green hydrogen, and what role are companies playing. This is what I'm going to discuss in the subsequent slides. So the working principle for Acme Clean Tech has been the disruptions right from the inception. We started as a in the telecom sector by inventing a state-of-the-art technology, a PIU technology, which was which was patented, and it was very much instrumental in bringing down the cost of the calling rates at that point in time. From a seed fund of 20 lakhs, we attained and we grew to a company of 2,000 crores in just a span of 6 years. So that is the magnitude of the disruptions that we made. In 2010, the company diversified into solar business, and since then it's no looking back. We earlier also in our esteemed distinguished speakers, they have touched upon this, that how the solar cost when it started was 50 rupees plus, but then subsequently it came down. I'm happy to state that Acme Clean Tech was the first company to hit the grid parity price of 2.44 rupees per unit in 2018. And that was a point in time when the company thought of the kind of visionary which our promoter Mr. Manoj Upadhyay is. He thought of forward integrating and adopting the power trader strategy and making green hydrogen. But again, that was way ahead of times. The idea was way ahead of times. There was only the discussions were there were no reference points, and then no available pilots. So the company invested, and they commissioned the world's first pilot project, integrated pilot project in Bikaner for the production of a green hydrogen, green ammonia plant. And we have been operating it for the last 2 years, since November 2021 we commissioned, and since then we have been operating it. And with this, let me take you to a virtual trip to Bikaner, which will give you a idea as to how exactly an integrated plant runs. So can you please this is the project financing what we have raised over the period of time. Till now we have raised somewhere around more than $5 billion of project financing, and we are spread across. We have a global presence. We are based out of Gurugram, and we have a marketing office in Dubai, and we are based out of we have a working office in Houston. We are We are a representative office in London, Muscat, and Beijing and Tokyo. So we are deriving from operating Bikaner plant. Will be incorporating an upcoming plant in Oman, which will have a much larger capacity of 1.9 million metric tons. It will come in two phases. The first phase, 100,000 metric tons. We are happy to state that the world's first arm's length offtake agreement is in place. The FID is closed, and we are in the developmental stage, and it will get commissioned by 2026, 27, early first quarter of 2027. So possibly this is the second project world over after NEOM that will see the light of the day. In the same context, in India, we are working at two locations in Odisha. We have already secured the land parcel size of 343 acres in Tata SEZ, Gopalpur. And again, it will come in three phases. It's a 1.2 million metric tons of plant. The three phases will be comprising of 400 TPD capacity each. Happy to state that the first phase, the term sheet is already signed, the offtake term sheet is already signed with a Japanese company called IHI, and this is also in the developmental stage. Likewise, in Tuticorin, we have a similar set of plan to set up 1.2 million metric tons of green ammonia facility. And in US also, we are in a developmental stage of working and putting up a similar scale of plan in Port Victoria. So this is just to show a brief about what exactly and how we are positioned as far as our Oman plant is concerned. Typically, let me tell you how an integrated green ammonia plant looks like. It essentially comprises of four parts. The first part is the RE power generators, which is primarily produced by the PV module, the solar panels, and the wind turbines. The second part is the electrolyzers, which has also attached these desalination units. The electrolyzers, using the RE power, splits water to the process of electrolysis into its elemental forms, hydrogen and oxygen. Oxygen, as of now, it can be used as it can be retained and used as a medical and industrial usage, but it is ejected as of now. Hydrogen is retrieved, hydrogen is stored, and it is injected in the third part, which is the ammonia synthesis loop, which also is connected with the ASU. ASU is a air separator unit which captures nitrogen from the atmosphere and combines with the hydrogen, and through Haber's wash process, now ammonia is created. Ammonia then goes to the third phase, it is stored, and then it is shipped to the destination points. So this is the current offtake agreement, as I said, with Yara International. Yara International is one of the leading fertilizer manufacturing companies in the world, and this is the site description for our Gopalpur Odisha plant, which says that this plant is non-integrated, which means essentially that the power will be generated somewhere in Rajasthan, and through the ISTC network, the power will be brought down to our location in Gopalpur, and it will be used to generate green hydrogen and its derivative, which is ammonia, or maybe other derivatives like green methanol, etc., and it will be then shipped to the destination points. Again, the land is acquired, as I said, and then we have signed a deal with the Conclave, who is the technology provider for our ammonia synthesis loop. And this is a brief description about our USA project in Victoria Port. So, sharing the
monthly average carbon dioxide concentration levels from last 3 centuries. In 1700 and 1800 century, it was pretty flat, close to 275. But if you look at the last 75 years, you will see an exponential rise from 275 crossing up to 400 ppm level. And this is really alarming, and that's why I said we need to think fast and act fast. Carbon is the foundation of our material world. Carbon is in the products we use, be it perfume, the clothes we wear, or the planes we fly, the laptop, the mic, the chairs you are sitting on. So carbon is the backbone of everything. There is no escape from carbon, and carbon is in the natural world. In total, I would say carbon is in us. So what defines this carbon is where this carbon comes from. This will define our climate future. So as of today, most of the climate is coming from the ground through crude or like coal or these channels. And at LanzaTech, we believe we have enough carbon above ground to make everything we need for our life and use. Step one is about reducing carbon emission, and a lot of people talked about how we can improve process and optimize the plant use or better process controls to reduce the CO2 emission per ton of steel. And that's always would be the low-hanging fruit and first thing we would go after. But at the same time, we need to look into the power of circular economy. So the point is, it's not possible to get rid of the entire off gases or CO2 from the steel. We can reduce it to some level, but at the same time, we provide you, the steel industry, the technology to convert this CO2 into more meaningful products. So globally, we have 4 units which are operating. The first one is steel mill emission off gas based. All 4 units are in China. And all of them are operating. The first one was commissioned in 2018, the second one in 2021, the next one 2022, and then 2023. And slowly you can see we have also increased the capacities from 46 to 60,000 tons per year of ethanol. And one of the unit is based on steel mill off gases, and the 3 are based out of ferroalloy off gases. The 2 more units are based on the off gases. I would say industrial off gases. These 2 are in the commissioning stages, and the first one is at IOC Panipat, which is under commissioning right now, and the other one is at ArcelorMittal steel plant in Belgium. With ArcelorMittal, Sekisui, Suncor, NextChem, Brookfield, IOC, Woodside, Shougang, to name a few. And if you look at the right side on the chart, these are the plants we are having. On the left side, it's the Suncor bottom. In the American region, it's a Freedom Fine Facilities in Georgia. That's the world's first SAF, Sustainable Aviation Fuel Production facility owned by LanzaTech. In Europe, we are working on some projects. And then there are 4 projects on the right. They are all 4 units that we are operating in China. And in India, the IOC is in commissioning stages, whereas 2 more projects, one with MRPL and one with ACID, they are in the advanced stages. And then there is one in Australia. 6 plants running. We anticipate 500,000 tons of CO2 abatement, and it's not just abatement or capturing CO2 and put it in underground or somewhere into the sea. With this kind of CO2 abatement, we are producing 300,000 tons of ethanol. So that's where we talk about the circularity, getting the carbon from these off gases and converting it into useful products like ethanol. And ethanol is just the starting point. This is LanzaTech process. So first one is the compressor, the second one is the gas cleaning. So we need a moderate gas pressure to run the gas to the reactor. So once the gases are compressed and cleaned, if there are any impurities, it is diverted to the fermenter, which is our bioreactor, where the magic happens. The microbe, LanzaTech proprietary microbe, they convert these off gases containing CO2, CO and hydrogen into ethanol. And then the last column is the distillation, where water and ethanol separation takes place. And finally, the ethanol is routed to the storage.
India, and you referred about how green hydrogen is being used in the steel production. Can you provide us any instance in the Bharat project where green hydrogen is being used in the secondary steel production in India?
You see, as my presentation I had already mentioned, that we are in touch with almost all the leading green manufacturing plants in the country, and we are actively in active discussion with one of the leading manufacturer of which is involved in the blast furnace technology, and we are working with that. So see, the point is that it's not yet established, but then it's still in the discussion phase. The technical discussion is almost through. It has been accepted, and then we will be progressing with the commercial discussion. So that is something to be lined up. So,
what has been the response from the secondary steel manufacturers in terms of adoption?
adoption is high. As I said,
Adoption, their response.
Sir, You are the mentor of entire industry, and I have been interacting with you right from my Mekong days. So you have been kind enough to interact with us. So actually now I am in Energy Efficiency Services Limited, and how we can collaborate. We are in Ministry of Power, not in Ministry of Steel. So and this is actually what we are doing. I will tell you, so that how we can collaborate, how we can make use of each other, and in our decarbonization journey, which is the goal of EESL, and which is the goal of entire industry. So what is there actually? What Energy Efficiency Services Limited has got a mandate of identifying processes, technologies, appliances where energy efficiency options can be implemented. Let's say we'll start with a very basic thing. When the LED bulbs were brought in, when GLS bulbs were there. So when it was brought in, it was piloted first, and then it was in upscale production was got it done through Energy Efficiency Services Limited. So that way, this LED bulb has socialized in entire India. So that is the main aim of EESL, that technologies are to be socialized so that entire India is getting benefited. Then only the net zero aim of India of 2070 will be fructified. If one industry or one pocket, one area, one state is only using that technology or is advanced in that technology, then our purpose is not getting solved. So that is what we are doing. So in this sector also, in the steel sector also, we are trying to find out certain processes which can be replicated. That replication is very much important in this. So that kind of module. So all entire PhD Chamber of Commerce and the entire industry has to help each other. So as to find the replicable models. For example, I will take motors are already there. Motors are very appliances sort of. Motor chillers are there, cooling towers are there. These are the energy efficiency will come in when we will use top recovery turbine also. Energy, you will be utilizing energy, and if you will be replacing motors, then energy efficiency will be replacing by energy efficient motors, and energy efficiency will come. So these kind of areas which are quick wins, and these areas are not as if you change technology from one blast furnace technology to other blast furnace technology in the group through green hydrogen, there may be enormous kind of energy efficiency you are gaining, but the transition is very slow.
Me the opportunity to present our company like KJSS Cosmos, which is a startup company. We set up this company in the month of December 23. After I left the job at SR and started my own business. And we have developed many products, and the major aim is the digitalization of the steel industry. With that aim, we set up this company. So basically, by looking at this QR link, you can download our main corporate presentation. And with this link, you can find out the presenter information about me. Basically, in this presentation, I am going to cover the complete techno-commercial comparative of the different steel making process, specifically covering about coal-based DRI, because that's the thing which I found it was missing in this, and how to do the CO2 calculations, like how much CO2 we are producing through different steel making processes, and capturing the CO2, utilizing the CO2 within the steel plant itself, and what are those plants where this is being done. So this is just in brief about our products. These are the unique products developed by KJSS. First is PROCA, Procurement Assistance, which can reduce the ordering time of the steel plant equipment and capex equipment, large equipment, and the MRO items to it can reduce by 80%. The actual time which we take 10 months, that will be reduced to 2 months. all technical comparison, commercial comparison is being done through artificial intelligence, and the system is giving the rating. So detailed presentation you can find on this link. You can go through that. Our product is plant on cloud. Basically, we have taken all the data of the plant, ERP system, and the other areas on the cloud, and then for a particular person, whatever information he is needed on the real-time basis can be given to on his mobile. And we are making its presentation to JSPL on this Monday, and with on live data. We have set up a small engineering company also, which is taking care of right now cold rolling mills and the processing line engineering. And the another technology which we are working is like for coal-based DRI, sponge iron producer through coal-based DRI. They are cooling the sponge iron with the water. So we are suggesting a technology where like if they are cooling 1 ton per hour of sponge, they will get in return 0.5 ton of steam and high saturated steam. So if we do the sponge iron dry cooling. So the complete presentation is there on that link.
So the basic content of production of this presentation will be a basic introduction to Canthal, why electrification is important, what are the key enablers for electrification for fossil-free steel, and a few case studies within the steel processing industry where we have applied our technology and how it is working, with a basic summary and conclusion of how much CO2 emissions we have stopped as of now. So as Canthal, we know electrical heating technology. We are a company founded in 1931 and we have a rich experience of more than 90 years in this field. So Canthal is a pioneer in electrical heating technology. It was founded by Hans van Canzo in 1931. We have material expertise in solutions up to the temperature of 1850 degrees Celsius. We have multiple heating solutions available with us, and we are a global R&D organization. We have a setup in Pune as well, wherein actual simulations can happen, and you can see the product working and the process working before you put a lot of investment or a lot of money beforehand. So now coming to why electrification, why we are here. These are the 5 key benefits of electrical heating as compared with the fossil fuel one. Electrical heating is up to 95% efficient as compared to the gas one, which is only in the range of 40 to 60%, because there is a lot of considerable losses in case of like flue gases, which can't be recovered 100%, and that's why the efficiency is within the range of 40 to 60. Whereas for electrical it is 95%. So this makes your furnace size smaller. This makes the whole energy requirements go down, and it makes for a very safe and quieter production environment. It also eliminates NOx and SOx emissions. The temperature control is quite brilliant. You cannot get that in case of fossil fired fuels like gas heating or FO furnace oil heating and all. In electrical you can get even up to plus minus 1 degree Celsius, and it helps in reducing CO2 emission, and it can be zero if renewable energy is used. These are the key enablers for electrification. So as informed earlier, we have a unique materials portfolio. We have metallic range. We have nickel chromium solutions, ferrous chromium alloy, aluminum alloys, which can go up to 1350 degrees Celsius. And then we have ceramic solutions, which can go up to 1850 degrees. With this 90 years experience, we have extensive application know-how, and we have pilot test, scale testing and modeling capabilities with us. So what do? We accelerate electrification for a sustainable business. We have identified a few areas in the steel making application wherein we can use electrical heating as compared to the normal fossil fired one. So in iron making, this electrical preheating of gas which is going into the blast furnace, let it be syngas, let it be hydrogen, whatever it is, can be heated electrically through our systems. We also have heating for hydrogen before it is put in the mid-rex shaft. So heating of hydrogen for DRI furnace is also one of the things that we are doing for green steel production. We are a proud collaborator in the hybrid project which is happening in Sweden. Recently we have been in a collaboration with Danelli. You can also find that in the Steel magazine on page number 36, that we have collaborated with Danelli on supplying this Prothal, what we call, for this heating of hydrogen for DRI application.
So,